Good afternoon, students. We are discussing about testing of logic circuits. Okay, and in that, in earlier lectures, we discussed about how to test combinational circuits. In that, we have seen faults like stuck at 1 and stuck at 0. So that means if any wire is continuously connected to 0, then we call it as a stuck at 0. And if it is continuously connected to logic 1, then we call that as a stuck at 1. So because of that, even though we are applying a certain input to combinational circuit, but we will get unwanted output. That means that will not be correct. It will be false output that we will get at the output of that circuit. So for the testing of that circuit, we have this stuck at model. Then after that, another type of method, that is a path sensitization. So that also we have discussed, and after that one random test, uh, that method also we have discussed in the earlier lecture. Okay, am I audible to all?
Yes, ma'am.
So now in today's session, we are going to discuss about how to test sequential circuit. So as you know that in a combinational circuit, whatever input that we are giving, depending on that only, we are going to get output for that circuit. Okay? But in a sequential circuit, that is not the case. Okay? Output of that circuit that depends on the input that is applied at the same time previous state output. Okay, that is also required, or that is also responsible for the output in the current state. Okay, so that means here because of this requirement, the sequential circuit testing that becomes more difficult, okay, as compared to combinational logic circuit. In a combinational logic circuit, as we can have a test vector in any of the methods, that is a deterministic or the random test. Okay, so in any one of these methods, we can apply a test vector and then we can check for the output, and then we can decide whether the circuit is faulty or not. But we cannot do this in a sequential logic circuit. Here, because of the presence of memory elements that allows a sequential circuit to be in a various state. As what we are considering the previous state output, and because of that, sequential circuit that will remain in a various state, and because of that, the response of the circuit to any externally applied test input that will depend on the previous state in output and current input. Okay, and this is the big problem that it is difficult to ascertain that the circuit is in a specific state. Okay, so that means we cannot assure that in a previous state circuit was in this state only, and then we can continue with that. Okay, so that is not possible in a sequential circuit. So here uh, even though we are considering each transition of that sequential circuit to be tested, it is necessary to verify with complete certainty that correct destination state was reached. Okay, that means even we are considering each and every state of the sequential logic circuit, but whenever we are considering it at particular testing point, that time we need to verify that the particular or the correct state was reached when we are considering or when we are testing that sequential circuit. Such an approach may work for very small sequential circuit. Okay, now we can apply each and every test vector to the circuit, and then we test that sequential circuit. But if that circuit is small one, then it is possible, but otherwise it is not practical for large size circuits. Okay, so that means practically the circuits are not of a small size. We cannot consider a single circuit only. So that means we cannot consider just a flip flop. Okay, it will have so many number of flip flops in that circuitry, and so we need to consider that situation and that is why this method will not be feasible to test each and every vector for the sequential logic circuit. So it is needed that a better approach to uh, that should be available to test a sequential circuit, so that we can easily test that circuit. And that is why we are going to study about some different types of testing methods or testing technologies that are used for testing of sequential circuits. Okay. So the first testing method that we are going to study, that is a scan path technique. Okay. So here you can see a diagram in which we have a combinational circuit, then we have multiplexers and a, flip-flops. Okay, so these flip-flops that are present in that circuit. So this is just a methodology or a general structure of the scan path testing method. Okay, so here what we are doing, we are using multiplexers uh, on a flip-flop input. Okay, so here you can see that we have used three multipliers, 2:1 multiplier as a as the input of these flip-flops. Okay, there are three D flip-flops that are present, and for each of this input of D flip-flop, there we have used multiplexers. Okay, so these allows these multiplexers that allows that what input should be present at the input of flip-flop. Okay, so these multiplexers that is deciding what whether we are going to work in a normal operation or we want to scan the circuit. Okay, so here for this purpose, scanning purpose, the select input that is given to the one terminal, that is the non-op. If normally, then we are going to select whatever is the output of the combinational circuit, that is the Y1, Y2, and Y3 as the input to this D flip flop. Okay, so that means this circuit will work in a normal operation. Okay, of that sequential circuit. Or if we are making this as a scan, that means if we want to scan the circuit, so we have to keep this as a high logic level, and if it is at a high, then whatever is the previous state that will be applied at so that means this will be selected as the input of D flip flop. So here we can see that we have three D flip flops and the multiplexers which are connected at the input of this D flip flop. Okay, so this is the general scan path structure which for a circuit with three flip flops. Here 2:1 multiplexer connects the D input of each flip flop either to the corresponding next state variable or to the variable path that connects all flip-flops into a shift register. Okay. Uh, it is observed that when I started this meeting, there were 50, more than 50 students in this meeting. I think they have just replied in a chat box and then they have left this meeting. They have left. Now I am going to call each and every student and then depending on that, I am going to take attendance. Okay, keep this attendance. So be sincere while attending these lectures. Okay. So now randomly I am going to call any one of the students. If he is present in the meeting, then only I will put his attendance or her attendance. Otherwise, I am going to mark him or her as an absent. Uh, so, Rishikesh, Tell me how we test combinational logic circuit. What is stuck at one? Rishikesh, are you there in a meeting? Snehal? Snehal Purani? Rishikesh More? Utkarsha? Utkarsha, are you there in the meeting?
हाँ मैडम.
Okay. So tell me what is stuck at one? What is mean by stuck at one? When we call that wire is stuck at one, कधी म्हणतो ते stuck at one आहे?
हॅलो मॅम.
Yes.
हाँ स्नेहल इज हियर मॅम. रेंज प्रॉब्लेम होता म्हणून रिप्लाय दिला नाही मी.
Okay. So tell me now. You tell me.
हॅलो. हा.
When we, huh?
0 इनपुट असेल तर.
Zero input असेल तर stuck at one. Are you getting all of you? Huh? This question is not just for Snehal, for everyone. Are you getting what we are discussing?
Yes, ma'am.
Okay. So my question again. Just I'm going in basics. Okay. Just that means whatever we discussed earlier. What is stuck at one? आपण आपण जेव्हा actually what we are doing, we have in the earlier lectures we have written code in two different HDL. Okay, that means we have discussed code, how to write a code in a Verilog as well as VHDL for certain different circuits. Now once we write a code, we will, and after synthesizing we will get certain model for that circuit. Okay, but when we are going for the chip level design, that time there may be certain problems that would have arise in that circuit. Okay, कारण आपण जेव्हा कधी पण सर्किट करणार आहे तयार तेव्हा इवन यू मस्ट हॅव एक्सपिरियन्स दिस इन युअर लॅबोरेटरी की तुम्ही सर्किट करताय आणि तुमचं कनेक्शन चुकीचं झालंय. ओके, ज्यावेळेस ते सर्किट एवढं मोठं तुम्ही रेजिस्टर्स वापरत असता, ट्रान्झिस्टर्स वापरत असता आणि त्यावेळेस सुद्धा तुमचं कनेक्शन चुकीचं होतं काही, किंवा तुम्ही जर पीसीबी वरती माउंट करत असाल तर मे बी तुमचा ट्रॅक शॉर्ट होतो. ओके, सो लाईक दॅट वे in when we are doing it at a micro level, that time there may be certain faults that would have present in that circuitry. So we need to detect that fault before we launch that product, whatever IC we are developing. So before launching that in a market, so we need to find out that whether there is any fault or not, and we should discard all the faulty ICs. So for that, what we are doing, we are testing that circuit before fabrication. Okay, and for that we have certain different methods. So here we discussed about some techniques in the previous lectures. So now what are that faults? That it may happen that whatever connection we are having in between the input and internal connections, that wires may be shorted to zero logic level or high logic level. Okay. If it is connected to zero logic level, then we call that wire as a stuck at zero. Okay. So that is a one fault, that it is stuck at zero. That म्हणजेच आपण काय म्हणू शकतो की त्याला ते कायमच कनेक्ट आहे, कुठे कनेक्ट आहे, झिरो लॉजिक लेवलला. आणि दुसरा फॉल्ट काय आहे की your wire it may be permanently connected to high logic level. Okay, so that means it may be permanently connected to a 1. Okay, so एकतर ती ground ला connected असेल किंवा एकतर ती VCC VDD ला connected असेल. Okay, so any of the faults that may be present in the wire. Now we need to detect whether there is any fault or not. Okay, and for that we have different methods. So to find out that, what we do in the first model, what we did, we are applying the inputs to the circuit, and depending on that we are comparing the result with the correct result. Okay, म्हणजे आम्ही काय करणार आहे, मी इनपुट देणार, जे काही तुमचं सर्किट असेल त्याला इनपुट देऊन बघणार आणि त्याच्याप्रमाणे आउटपुट जे काही येणार आहे ते कम्पेअर करेन. कशाशी कम्पेअर करणार आहे, तर आधीचा जो काही रिझल्ट आलेला आहे त्याच्या, म्हणजे जो करेक्ट रिझल्ट आहे त्याच्याबरोबर ते कम्पेअर करेन. आता जर या दोन्हीमध्ये डिफरन्स असेल तर याचा अर्थ काय आहे की माझा रिझल्ट हा रॉंग येतोय, अँड देन आय हॅव टू डिस्कार्ड दॅट आयसी बिकॉज ऑफ ऑर दॅट सर्किट बिकॉज इट इज अ फॉल्टी. ओके, आता हा फॉल्ट कम्प्लीट सगळ्या तुमच्या डिझाईन मध्ये जरी असू शकतो किंवा मॅन्युफॅक्चरिंग करताना प्रत्येक आयसी मध्ये असू शकतो. ओके, म्हणजे एखाद्या आयसी मध्ये हा प्रॉब्लेम झालेला असू शकतो. सो दॅट मीन्स यू नीड टू चेक ईच अँड एव्हरी आयसी before sending it to the market. And for that we have this different testing methods. Okay, now we are developing a certain model, and from that we are checking whether the circuit is faulty or not. Again we have another method, that is path sensitization. Okay, so in that what we are doing, we are uh, giving input to only one of the input signal, uh, okay, that we are going to vary, and for the other input terminal, for each of the logic gates that is used in the circuit, we are keeping it in such a way that output of that logic gate will not dependent on other input. Okay, that means only one input that is going to change the output, others will be just in a such a condition that they will make that they will not make any difference in the output. Okay, and then we are going to check for the output, and that means we are making one path active, and we call that as a path sensitization. Okay, in a technical terms we call that as a path sensitization. Now in any of this method we need not to use all the vectors. Okay, all the test vectors, म्हणजे जे काही कॉम्बिनेशन्स आपले इनपुटचे असणार ते सगळेच टेस्ट करायची गरज नसते. तर ठराविक फक्त तुम्ही घेऊन तुम्ही सगळ्या टेस्ट पण करू शकता, म्हणजे कुठे फॉल्ट आहे का दॅट यू कॅन सी. ओके, बट स्टील for the large input circuit that becomes a little bit difficult, and that is why we go for the random test. That means we are selecting just a random vector, and from that we are testing for whether the circuit is faulty or not. So these are the methods that we used for the combinational logic circuit. But when we are going for the sequential logic circuit, in that we have the memory element. That means output of that circuit that is dependent on the previous step, and that is why we cannot use earlier methods directly for the testing of sequential circuit. You can do it for smaller circuitry, but for the larger circuit it is not possible, and that is why we are going for the circuits for the different technique, and one of the techniques that I am discussing right now, that is a scan path technique or scan path testing. Okay, all of you got up to this? Snehal?
Yes, ma'am.
Okay, so now we are discussing about scan path testing. Now here what we are doing, we are using multiplexer on the flip-flop input. So these are the flip-flops, these are the memory elements, and also with these we have certain combinational circuits. Okay, so it may be any circuit that may be present here, but with that we have this flip-flops. That means overall this circuit will be a sequential circuit. Now here at the input of these flip-flops we are using these multiplexers. So what these multiplexers are doing, these multiplexers will select any one of the inputs which is present at the inputs of these multiplexers, which will be present at the inputs of the flip-flop. Okay. Now, who is going to decide which input should be present at the D flip-flop? What is multiplexer? Sunil, what is mean by multiplexer?
Many to one.
Many to one. The circuit which converts many inputs into one, that we call it as a multiplexer. So how we are getting that one input? So for that what we require certain select lines. Okay, and if we have 2 raised to n number of inputs, then we require n number of select lines. So here as it is a 2 to 1 multiplexer, so what we will require? We will require one select line. Okay. So here, this is the select line that we have for this circuit. Okay, which has the name, that is a normal bar or scan. Okay. So if we are using this circuit as a for the normal operation, that means we are want to use this circuit for the normal purpose, then we have to keep this at a 0. Okay. So that means if this is 0 at a 0 logic level, whatever input that is present at 0, that will be available at D. Okay. So that means whenever we have this select input 0, that time, or we can say this is the control signal, that is 0, or that time it will be in outputs, that is a Y3, Y2 and Y1, that are connected to this D flip-flop. Okay. But if when this control signal that is active, that time previous outputs that will be connected to the D flip-flops. Okay. Now here you can see the circuit connections. Output of this is again this is given to this combinational circuitry. So that means here this combinational circuit has the inputs, that is a W1 to W1 as well as this Y1, Y2 and Y3. Okay. And output of this combinational circuit, that is from Z1 to Zk, and then this Y1, Y2 and Y3. Okay. So this is the circuitry that is present. Okay. Now this is just a general structure for the scan path testing. Okay. Now let us see how this circuit is going to be work. Okay. So for the testing purpose, the shift register here, this flip-flop that works as a shift register. Okay. And whenever we are using it for the normal purpose, so depending on the inputs and the previous state, we will get the output. But whenever we are using this circuit for the testing purpose, that time these flip-flops that will work as a shift register. Okay. So here this figure, in this figure you can see that whenever we want that this flip-flops that should be tested, that time we are applying certain pattern to this flip-flops. Okay, so that means that time what we are doing, we are making this signal as a control signal active, and then through this scanning input we are giving the certain test pattern as an input to this circuitry. Okay, and then suppose we are applying a signal that is 0 1 0 1 1 0 0 1. Okay, remember what we are applying, input at this scanning, that is a 0 1 0 1 1 0 0 1. Now what will happen? We are applying a clock also to this flip flop. Okay, so depending on each of the rising edge of this clock, this input, that is a scanning input, that will get shifted, and at the output what you will get? Yes, at the output what you will get, Harshal? Harshal, are you there in the meeting?
Yes.
Okay. So if this is working now as a shift register, we have given the input at this scanning, that is a 0 1 0 1 1 0 0 1. Okay. What will be output?
D flip flop out.
Oh, okay. Tell me. D flip flop means? Yes, it is a D flip flop. Okay. Just forget about whatever was my question. Tell me what D flip flop does. D flip flop काय करतो?
जे इनपुट आहे तेच आपल्याला आउटपुट म्हणून मिळते.
येस, प्रत्येक क्लॉकच्या रायझिंग एजला तो काय करणार आहे, जे इनपुट आहे डी ला, इनपुट जे डी टर्मिनलला जे दिलेलं आहे तेच तुम्हाला आउटपुटला मिळणार आहे. बरोबर आहे. आता जर तुम्ही या सर्किट कनेक्शन बघितले तर आपण इथे काय केलंय, इथे प्रत्येक डी फ्लिप फ्लॉपला सेम क्लॉक अप्लाय केली. ओके, दॅट मीन्स वी हॅव कनेक्टेड सेम क्लॉक, म्हणजे प्रत्येक सिग्नलला, प्रत्येक रायझिंग एजला तुम्हाला इथे या सगळ्या फ्लिप फ्लॉप्सना काय मिळणार आहे, तुमचं आउटपुट चेंज होणार आहे डिपेंडिंग ऑन द डी इनपुट. ओके, नाउ आउटपुट ऑफ दिस, इफ यू लुक ॲट दिस, इफ आय से दिस फ्लिप फ्लॉप इज at output of this flip flop is connected as a input through this multiplexer to D. Okay, of D input of the second flip flop. Again output Y2 that is connected through this multiplexer to the D input of this third flip flop. Okay, so that will be Y3. Now when this output is going to be connected as the D flip flop, whenever scan normal bar or scan is active. बरोबर आहे. म्हणजे इथे जेव्हा आपण स्कॅन करणार आहे तेव्हा जे काही याचं Y1 चं आउटपुट, म्हणजे पहिल्या फ्लिप फ्लॉपचं Y1 हे आउटपुट आहे ते कुठे कनेक्टेड होणार आहे, दुसऱ्या फ्लिप फ्लॉपला. दुसऱ्या फ्लिप फ्लॉपचं Y2 हे जे काही आउटपुट आहे ते कुठे कनेक्ट होणार आहे, थर्ड फ्लिप फ्लॉपला. ओके, अँड देन यू आर गोइंग टू गेट Y3 आउटपुट. Now here we have applied a sequence or the pattern that is a 0 1 0 1 1 1 sorry 1 0 0 1. Okay, so earlier pattern that I said. तो आपण अप्लाय केला, काय होणार आहे, पहिल्या क्लॉकला काय, सॉरी पहिल्या क्लॉकला काय होणार आहे, पहिल्या क्लॉक रायझिंग एजला, so this 0 will be okay shifted. Okay, as this will work as a shift register, and then after 8 clock we will get here the pattern that is a 0 1 0 1 1 0 0 1. Okay, so that means whatever pattern that we are applying at this scanning input, that we are checking at this Y. Okay, And then depending on that, we are going to decide whether this circuit is working properly. That means these flip-flops that are working properly or not. Okay. And if it is working properly, then we are going for the testing of the combinational circuit. Okay. So once we decide that this flip-flops are working properly, we will shift for the checking of combinational logic circuit. Now here, what we are going to do, we are going to apply a test vector, that is W1 to Wn at this input terminal, and then Y1, Y2 and Y3, okay, here. So depending on that, what we will get? We will get certain outputs. Okay. So here these Y1, Y2 and Y3. Okay. So that time, as here we are going to test now operation of this circuit. So these Y1, Y2 and Y3 that will be connected here. Okay. And then we are testing for whether these outputs are coming or not. Okay. Properly we are getting this or not. Okay. So that time this will be inactive. So that means whatever is present at zero input of this multiplexer, that will be present at the D flip flop. Okay, and this will take 3 clock cycles. Okay, so here after that the W1, W2 and Wn, that means this input vector, that portion of the test vector that is applied to the combinational circuit, and normal operation of this sequential circuit that is performed for 1 clock cycle. Okay, and the outputs of this Z1, Z2 that are observed, the generated, okay, so these outputs that are observed and then generated values of Y1, Y2 and Y3 are loaded into flip-flops at this time. Okay, so that means initially what we are doing, we are just checking whether we are getting out Y1, Y2 and Y3 at this flip-flop, and after that we are checking for the keeping this normal and scan, normal bar and scan inactive, that means at a zero logic level. Whatever output that we are getting are the output of that circuit that we are checking. Okay, and as well as at this Y1, Y2 and Y3. Now, here, these Y2 and Y1, Y2 and Y3, these are once loaded at this flip-flop. Then what we are doing? We are making again this normal bar or scan equal to 1, and then contents of the flip-flops that are scanned during again next 3 clock cycles. Okay, म्हणजे आपण काय करतोय, पहिल्यांदा आपण जे काही Y1, Y2 and Y3 that is present at this input terminal, that we are checking, keeping this normal bar or scan that is 1, okay, using 3 clock cycles. एकदा ते चेक झालं की त्याच्यानंतर आपण काय करतोय, इथे जे काही इनपुट दिलेले आहेत W1 to W1, त्याच्यावरून Z1 to ZK पण ऑब्झर्व करतोय, आणि जे काही Y1, Y2, Y3 येणार आहे ते आपण या फ्लिप फ्लॉप्स मध्ये लोड करतोय. ओके, युजिंग 1 क्लॉक सायकल. And once we have loaded these values, then again we are making this scan, that is this pin active, this control signal active, and then we are checking shifting operation of these flip flops using 3 clock cycles. Okay, so here because of this, what happens? This makes Y1, Y2 and Y3 portion of the test result that is observable externally. Okay, so we can observe whatever is the result that is present, that is externally, that could be observed. Okay, so now here at the same time the next vector can be scanned in to reduce the total time that is needed to test the circuit. So whenever you are testing a certain circuitry, so when you are again scanning for this or shift register operation that you are doing in the last 3 clock cycles, that same time you can load next vector, test vector, and then you can reduce the number of clocks that are clock cycles that are required to test. Okay, so this is about the scan path testing. Okay, so now let us consider a specific circuit that can be used to uh, for a scan path testing. Okay, so that means using this technique, how we can uh, test certain circuits that we are going to check. Okay, so here what we have two flip-flops and there is a combinational circuit with a AND gate and OR gate. Okay, so you can see this circuit. Now what we have done, we have used a W input. Okay, so this is the single input that is present, that is W in the circuitry, and at the same time there are two uh, outputs of this D flip flop, that is a Y1 and Y2. Okay, so that means we need to apply a test vector, that is a W, Y1 and Y2, so that we can test this circuit. So here we can test this flip flop using zeros and ones sequence, so that whether it can be it is in a proper condition or not. Okay, so once this circuit, once we find out that this is working properly, then we can go for the combinational circuit testing. Okay, so for that we are applying a test vector, that is W, Y1 and Y2. Now let us say that we are going to apply four test vectors. Okay, so the first vector is a 0, 0, 1. Okay, now suppose Y1, now again look at the connection. So we have Y1, which is the output of this flip flop, which is connected to the input of these two AND gates. Okay, then Y2, that is connected to the input of this AND gate, that means here input to this AND gate. Okay, whether my cursor is visible to you?
Yes, ma'am, it is visible.
Okay, so here for this flip flop, okay, this flip flop's output is connected to, I'll say this as a first one AND gate as a 1, 2, 3 and 4. Okay, and fourth AND gate output is a Z output. Okay, and inputs are Y1 and Y2. Okay, for the third AND gate, input is, one of the input is W and another input, that is Y1. Okay, then for the second AND gate, one input is a W and second input is a Y2. And for the first AND gate, one input is a W and another input is a Q bar. Remember that it is a Q bar that is connected as a one of the input to this AND gate. Okay, now output of first AND gate and second AND gate is connected to the OR gate, which is giving us the output, that is a Y1, and output of second AND gate and third AND gate is connected to the second OR gate. Output of it, we are calling it as a Y2. Okay, and then output of fourth AND gate is a Z. Here, now these Y1 and Y2, these are connected to this flip flop through the multiplexer. Okay, so this is connected to the zero input. Okay, here I have stated it as a 0, so I will call it as a 0 input. And for one input, that we have for the second multiplexer, we have Y1 as there as an input, and for the first multiplexer there is a scan in input. That means we are going to apply a pattern, test pattern at here. Okay, and here whenever we have this control signal at an active that means at a high logic level, whatever input that is present at scan-in, that will be applied at a input of D flip-flop. Okay, so this is the circuitry. Now, suppose I am applying a test pattern that is a 0, 0, 1. That means W is equal to 0, Y1 is equal to 0, and Y2 is equal to 0. Okay, so in another way, now I'll say that yes, first of all, what we are going to check? We are going to check for this flip-flops. Okay, so and then combinational logic circuit. So whenever we have applied a first vector, that is a 0, 0, 1, so what will happen? Y1 is equal to 0 and Y2 is equal to 0. Okay, now that we are going to check with a 2 clock cycles, because here we have only 2 clock signals, 2 flip-flops. That means we will require 2 clock signals to check whether they are operating properly or not. Okay, so that means we need to first do a scan test. So we will keep this signal at a high logic level, so that whatever we are applying at a scan-in, okay, that will be present at a D flip-flop. Okay, so here we will apply 0, 1, and then we will check whether it is we are getting 0, 1 at the output or not. Okay, now then for one more clock cycle, we are applying, we are using this circuit in a normal mode. That means we will make this signal inactive, and then we are applying 0 at this input W. Okay, so that means total vector that we are applying is a 0, 0, 1. Okay, and then that will be applied to this combinational logic circuit. So here, as Y1 is 0 and Y2 is 1, that means our Z output, that is going to be equal to, what will be value of Z output? Abhishek, what are the inputs to fourth gate? Z output तुम्हाला कुठे मिळतोय? फोर्थ अँड गेटला. ओके, त्याला इनपुट काय काय आहेत? Y1 आणि Y2. So Y1 is a 0, Y2 is 1. So what will be output of this gate? Satyajit? Hello Satyajit, are you there in the meeting?
Ma'am.
Okay, so tell me, AND गेटला एका AND गेट इनपुट टर्मिनलला 0 आहे, दुसऱ्याला 1 आहे, काय आउटपुट मिळणार आहे?
0.
Yes, it will be 0, correct. So that means we will get Z is equal to 0. Okay.
0.
Now we want to see Y1, what will be Y1 and Y2? Our W is 0. Y1 in this input terminal, म्हणजे previous state input output काय आहे? Y1 आणि Y2 चं 0, 1, 0 आणि 1 आहे. तर हे आउटपुट काय मिळणार आहे आपल्याला? Y1 आणि Y2 काय मिळेल?
0, madam.
Both will be 0.
0.
Okay, so that yes, Y1 पण 0 असणार आहे, कारण Y1 0 आहे, जे कुठे कनेक्ट केलेलं आहे, आपण थर्ड ला कनेक्ट केलेलं आहे, तर इथे 0 असणार आहे. त्याच्याबरोबर Y2 इथे आपण कनेक्ट केलेलं आहे, जे 1 आहे, पण W 0 आहे, म्हणजे याचा आउटपुट पण 0 आहे. या अँड गेटचं इथं W कनेक्ट केलेलं आहे, जो 0 आहे, म्हणजे फर्स्ट अँड गेटचं पण आउटपुट 0 आहे. सो वी विल गेट Y1 इक्वल टू 0 अँड Y2 that is equal to 0. Okay, so that is correct, very correct. म्हणजे आपल्याला काय मिळणार आहे? Z equal to 0, Y1 equal to 0 and Y2 equal to 0. Now these values, that is a 0, 0, that are again loaded in the respective multiplexer. Okay, so that means respective flip-flop to this multiplexer. And then for the next clock cycle, they are scanned out. Okay, so that means again we are using a scanning mode here, and then we are taking a output of this flip flop, and then we are checking for the scan out output. Okay, so here this depending on this, we are checking for one test vector. Okay, so that means for the first here, for the first loading, whenever we are loading the or scanning the flip flop, that time we require 2 clock cycles. Then for the loading of the output of this, we required 1 clock cycle. Y1 and Y2 in the flip flop, we required 1 clock cycle. And again, for scanning out results, we required 2 clock cycles. So that means we required overall 5 clock cycles to perform one test. Okay. So similarly, if we are applying for the another test, okay. Now, whenever we are scanning for this test signal, okay. So that time we can load next test vector, okay. So that we can reduce 2 clock signals there. ओके म्हणजे जेव्हा आपण शेवटचं स्कॅनिंग करतोय त्याच वेळेला आपण पुढचा टेस्ट वेक्टर लोड करू शकतो अँड देन वी कॅन रिड्यूस द number of clock cycles. So if we require, we are going to test 4 test vectors. So actually for each of the test vectors, we may require 5 clock cycles. That means total 20 clock cycles. But actually we are not going to use these many clock cycles, but for the first test vector, there will be 5 clock cycles, and then whenever last scanning is going on, that time we are loading the next test vector. So 2 clock signals, 2 clock cycles that can be reduced, and then we can have only 3 clock cycles for next vector. So second, third, and fourth test vectors will require only 3 total 9 clock cycles. Okay, so that means if we are going to test this circuit with 4 test vectors, we will require only 14 clock cycles. Okay, and from that we can test this circuit. Okay, so this is the way how we are doing a scan path testing. Okay, so this is the one of the method that is used for sequential logic circuit testing purpose. Okay. So anyone has doubt about this circuit? काहीच समजलं नाही असं कोणी आहे का? कौस्तुभ, are you there in the meeting? Hello Kaustubh. Kaustubh. Vishakha. Hello Vishakha. Imran.
Yes, madam.
Do you have any doubt? समजलंच नाही, काहीच नाही समजलं, कुठल्या स्टेज मध्ये आहे? पायल, इमरान, रिप्लाय.
Yes, madam.
समजलं मॅडम.
Okay. Have you understood, Payal?
Yes, ma'am.
Okay. So this is one of the method. In the next lecture, we are going to discuss about another testing method that is a built-in self-test, which is also abbreviated as a BIST. Okay. So in the next lecture, we will discuss about that testing technology. Okay. For today, now we will stop here. Okay. But remember that I have noted attendance of each and every student for today's lecture. Okay. And it is found that most of students that are coming just They are replying in the chat box for their attendance and they are leaving this meeting. Okay. So those who are not present till the last moment, today I am going to make them as absent or mark them as absent. Okay. So you may leave for today.